In this modern world of technology, computers have become an essential part of life. This complex-looking device may not be a child's play, but it is indeed a fascinating and challenging device for the human mind. Just having access to the computer is not sufficient. Every individual who works on it has to put in certain amount of effort to achieve the end results. These people are engaged in the activity called software development. But what is meant by software? And why does a computer need software? If we have a simple equipment which is meant to do only a few jobs, then for its operations we need very few instructions. However, when a machine or device does many jobs, then the situation is quite different. We need details and accurate instructions for its operations. To cite an example, we have taken a lake, and here is an operation chart. As the name itself indicates, the operation chart shows instructions for the operator as to how one should make a stud pipe using the lathe. The operator has to be given different set of instructions to produce different parts. Another interesting example is that of the calculator. Here are a set of instructions telling us what keys to press to compute the mean and standard deviation for a set of numbers. Different instructions are required for different computations. Thus, there are two components involved in doing a job on a general-purpose machine. First is the physical equipment itself, and second is the set of instructions to be followed for doing the job. The physical equipment is called hardware, and the instructions are called software. Computer, being a general-purpose machine, needs software in addition to hardware to solve a problem. The software is also known as computer program. There is one important difference between the instructions for a computer and those of a lathe. In the case of a lathe, the instructions are given for the human being, whereas in the case of a computer, the instructions are given to the machine itself to be executed automatically. As the program is to be understood by the computer, it is written in a language which is extremely precise. It is called machine language. Computer hardware is designed to deal with on-off states of its components. Hence, the machine language instructions are made of strings of zeros and ones. This is a small machine language program that adds two numbers. In executing an instruction, different components of the computer participate. Look at what happens when the following instructions are processed. When its turn comes, a copy of this instruction is transferred into instruction register. Then it gets split into its components and is decoded. The instruction says, add the contents of memory location 11 to the contents of accumulator and store the results in the accumulator. Accordingly, the contents of location 11 get transferred to arithmetic and logic unit along with the contents of accumulator. The arithmetic unit adds the two numbers and the result is transferred to the accumulator. The machine language differs from computer to computer. It is extremely difficult for programmers to write the programs in machine language. It requires all the instructions to be written in zeros and ones, which makes it very difficult for programmers to read. Even if there is the smallest mistake made in writing the program, it becomes very difficult to locate and correct the mistake. To overcome this difficulty, the programmers can write their instructions using mnemonics in place of zeros and ones. The mnemonics are close to short English abbreviations for what the instructions stand for. Therefore, they are easy to remember. Such instructions are known as assembly language instructions. The programmer writes his instructions in assembly language, but the computer can execute only machine language instructions. Therefore, an assembly program has to be translated into machine language program before execution. This translation is done by a program known as the assembler. The assembler program is supplied by the computer manufacturer along with the computer. Machine language to assembly language is definitely an improvement for the programmer. Still, it is far from easy to use the assembly language. First, each assembly language instruction is very limited in its power. Therefore, these programs tend to be very lengthy for even the simplest of problems. Second, the programmer has to know many details about the computer itself for writing assembly programs. Third, there is almost one-to-one correspondence between assembly instructions and machine language instructions. Hence, the assembly language program written for one type of computer does not work for another type. To simplify the programming procedures still further, higher level languages have been developed. The vocabulary of these languages is close to English and mathematics. One need not be a computer expert to learn and use these languages. The program you are seeing is written in a higher level language known as BASIC. It accepts two numbers from the user and prints the total. Here is a basic program and a corresponding machine language program by its side. The basic program is the more readable of the two. Just like an assembly program, a higher level language program too needs to be translated into machine language before it can be executed. This translation is done by a program called compiler. Higher level languages are generally independent of the features of any specific computer model. Hence, they can be easily transferred from one computer model to another. Hundreds of higher languages are in existence today. Each language is particularly convenient for a certain type of task. Fortran for scientific computing, COBOL for business data processing, Lisp for artificial intelligence applications, and so on. The computer is usually used by several people. It is indeed difficult for a human operator to carry out this task. We therefore need a computer program to do it. Such a computer program is called an operating system. The operating system is also capable of doing several other jobs. It allows a user to store his programs in the computer for a long time and retrieve them later. It can also maintain accounts on how much computer time each user has consumed. This brings us to the question as to how a program is developed. The program development is an iterative process consisting of several overlapping steps. First, the program designer has to understand the problem at hand thoroughly by reading, discussing, and thinking. Then, the designer has to plan out a procedure for solving the problem. We must not forget that the computer can only execute the instructions of a program blindly. It cannot invent a solution procedure by itself. Thirdly, the solution procedure has to be written unambiguously in the form of a flowchart or in the form of a pseudocode. The pseudocode and flowchart are only intermediate steps in the program development process. They do not constitute the program itself. They only help to document the program logic. The next step is to choose a program language and convert the flowchart or pseudocode into a program. Lastly, the program has to be entered into the computer and thoroughly tested to make sure that it does not have any errors or bugs. This is called debugging. Debugging is an important phase of program development and is very time-consuming. Even a small slip in debugging can cause havoc. Two people are very happy that they have confirmed reservation tickets for the train journey. But what happens when they arrive at the station? They are both fighting for the same berth because the same berth number is printed on both tickets. It is not their fault, but that of the program which printed their tickets. The final phase of programming is documentation. This consists of preparing a write-up for the users of the program and the other programmers who are likely to modify it in the future. Program development is an expensive process, requiring considerable expertise and time. For some of the common problems, common software companies develop and sell programs which can be used by a variety of users. Such general-purpose programs are called packages. For IBM PC-compatible computers alone, some 40,000 packages are reported to be selling in the market. The field of software offers hundreds of thousands of job opportunities. Today, the number of people working in the software area is much higher than those in the hardware sector. The cost of software development is on the increase, whereas the cost of hardware is on the decline. This is because the software requirements are growing rapidly, whereas the availability of software experts is not keeping pace. Therefore, with the mere acquisition of hardware, our problems do not get solved. Proper choice of language or package, careful development of bug-free software, and a lucid documentation of the system are of utmost importance for problem solving by computers.